Welcome to the online lecture of Math 1-1 Linear Algebra and ODEs. Today we are going to learn dimensions and rank. This is exercise 2.9 in your textbook. This is the part 1 of a lecture on dimensions and rank. First topic of this lecture is coordinate vector relative to basis. Suppose the set B has the vectors b1 up to bp and it is a basis for a subspace H. For each x in H, the coordinates of x relative to the basis B are the weights C1, C2 up to Cp such that x can be written as a linear combination of C1, B1 plus C2, B2 up to Cp, Bp. And the vector in Rp, which is coordinates of x relative to the basis B, can be written as C1, C2 up to Cp, which are the weights. This concept is called coordinate vector of x relative to B or the B coordinate vector of x. Let's try to understand this concept with the help of an example. Suppose we have three vectors b1, b2 and x, where b1 and b2 are a part of a set B which is the basis of subspace H. The task is find the coordinate vector xb for x relative to B. For the solution of this problem, the B coordinate C1, C2 of x satisfy this equation. We can write this equation in the matrix form as this. The augmented matrix of the above matrices can be written as this. By using reduced row echelon form, we will get the values of C1 is equal to 3 and C2 is equal to 2. So in the form of linear combination, we can write x as 3b1 plus 2b2. And in the form of coordinate vector xb of x relative to b can be written as this. This was the mathematical solution of the problem. Now we will find the geometrical solution of this problem. For a mathematical solution, we have the value of C1 which is equal to 3 and the value of C2 which is equal to 2. If I will put these values in this equation, the left hand side would be equal to right hand side. Look at this figure. Here we have vector b1. To draw a vector b1 in a rectangular coordinate system, we will move 2 units on x-axis and 1 unit on y-axis to find our vector b1. In the same way, we can draw vector b2 by moving minus 1 unit on negative x-axis and 1 unit in the y-axis. And if we want to draw our vector x in a rectangular coordinate system, we will move 4 units on x-axis and 5 units on y-axis. So we will reach our point x. But in coordinate vector xb, We will consider vector b1, b2 as a coordinate of the system. In such case, we will move 3 units on vector b1, which is the value of c1, up to this. So this is 1 unit, this is 2 unit, and this is 3 unit. And 2 units, which is the value of c2, along the b2, we will reach our point x. Alternatively, if we will move 2 units on along vector b2, this is 1, this is 2, and 3 units along the vector b1, 1, 2, and 3, we will reach our point x. So the matrix in 1 changes the b coordinates of a vector x into the standard coordinates of x. Consider another example. Here we have vector v1, v2, and x, where v1 and v2 are the part of B, which is a basis of subspace H, and v1 and v2 are linearly independent. Now task is determine x is in H, and if it is, find the coordinate vector of x relative to B. By using the same procedure as we solved the previous example, we can write x in the form of linear combination as this. This is v1, this is v2, and this is x. The augmented matrix of this can be written as this. So by reducing this matrix into a reduced row echelon form, we will get this matrix. And from this matrix, we can find the value of C1 and C2, which are 2 and 3 respectively. So we can write coordinate vector of x relative to B as this. So this is the basis B determines a coordinate system in a subspace H.